Okay, pre-calculus, we are doing day 4 in our unit of, let's see, properties of logarithms. Okay, all right, day 4. So let's kind of talk about these definitions first, and then we'll kind of apply them in example 1. So anytime you have a logarithm where there's no basis written, you say there's no number here, you can assume that's a base of 10, okay? And if we think about these logarithms in terms of if we write it as an exponential, which we've already learned how to do, think about what this means. B to the first power equals B. Okay, that's why log base B of B equals 1. Well, B to the what power equals 1. Take any base and put it to what power, and it's going to equal 1. 0. So log of any base of 1 equals 0, which is why, well, we'll get there in a minute. All right. So here, natural log, this is just, if I were to rewrite this, if I rewrote that as a logarithm, it would just be with a base of e. Now over here, these last two, again, if I write the second one as an exponential, b to the a equals b to the a, you can see. Or if I rewrite this one as a logarithm, log base b of a equals, the exponent, log base b of a. So that's where those come from. Now we're going to go ahead, and those b's are just a base, and we're going to apply that to actual bases that we're given here. So let me try to leave those on the screen here. All right. So the natural log of 1 is, and all that means is log base e of 1 equals, well, e to the what power equals 1. And that's just going to be 0. And this means log base 10 of 10 equals, well, 10 to the what power equals 10, 1. 4 to the 0 power equals 1. 2 to the what power equals 8. Now this one, if you think of this as 5 to the what power equals 5 to the 2x, that's just going to be 2x. So what happens is the log base 5 of 5 cancels out, and it's just the exponent that's left. This one, you can think of this a couple different ways. You could rewrite this as, all right, let me just hopefully not confuse anybody. Log base 3 of, if I rewrite 27 as 3 to the third power, okay, there's an x there. Those can cancel, and what we have left is 3x. So that's just 3x. Same for exponents. Okay, again, those are going to cancel, and we have left over x plus 2. Boom, x squared. Last one. Let me rewrite this one. This is log base 4 of, now 1 over 16 is the same as 1 over 4 squared. And if I write that as 4 to the negative 2, right, because that's the same as 1 over 4 squared to the x power, and then use my properties of exponents from algebra 1, I will see that that's the same as log base 4 of 4 to the negative 2x. So boom, it's just negative 2x. It's an x. All right, let's move on. So here are properties of logarithms that are extremely useful. So the log of a product equals the sum of the logs. So if you get the log of, we'll do practice. But if you've got a quotient, which is, two numbers that are being divided, it's difference. And the log of a power, you're going to take that power and basically throw it in front. All right, so what's going to happen is we're going to have problems, and you're going to have to rewrite them using those logarithms to help you get to where you want to go. So, next problem. Wait, where am I? Oh, did I? All right, just the last thing I want to mention here with these properties is that these rules work only if the bases are the same in the logarithms. So you got to make sure that bases are the same before you can, if you have an an expression that looks like this, you're not going to rewrite it like this unless the bases of the logs are the same. Here, they're assumed that they're both, written like this. They're both 10s. So, okay. We're going to move to example 2. All right, so if you are asked to expand a logarithmic expression, what that means is you want to break up the expression, the logarithmic expression, using addition and subtraction, so that every single log has exactly one single term as input with no exponents. So for example, here we've got an x and we've got an x squared. We really need to just have one, okay? So we're going to break those up. So what we're going to do is we're going to use those properties. So the first thing I'm going to do is I'm going to rewrite that radical as an exponent, okay? So I'm going to rewrite this as log base 2 of x times x squared plus 1 to the 1/2 power, okay? Because what that does is, now if you look back at the properties, I can take that 1/2 and throw it in front. So I'm getting rid of that exponent. So let me go ahead and I'm going to do that, but I'm also going to separate these because this is one term and it's being multiplied by that expression. So if this factor times that factor. So it's a number times another number. So since they're being multiplied, I can separate them with an addition sign. So I'm going to go ahead and do that, and I'm going to throw the 1/2 in front. Okay? So log base 2 of x plus, and take that 1/2, throw it in front, 1/2 log base 2 of x squared plus 1. Well, now I've expanded my expression, and I've got, in each expression, I've got just one input. And this exponent's okay. We just want to make sure we don't have exponents around the entire expression, like this 1/2 here. All right, let's move on. Okay, now we're dealing with natural logs. Okay, it's the same process. The first thing I notice is this vinculum, okay, which is the division. So I'm going to change this expression to subtraction. So let's go over here and write natural. And usually when we write ln, if I write like a number like this, like they have it here in that same kind of font, no one can really tell if it's a 1 or an n. So when we write this with handwriting, we usually use a cursive L that looks like this. Okay, so for natural log. Okay, that's just how I was taught. Okay, the natural log of the numerator minus the natural log of the denominator. Now let's be careful about this. Natural log of the denominator, because we have to subtract that entire denominator, okay? And also, we've got an exponent here, and we've got multiplication. We've got a 9 and an x to the 5th. So I'm going to go ahead and separate that using the multiplication. That 9 and that x to the 5th are being multiplied. So this is the natural log of 9 plus the natural log of x to the 5th, which I'm going to rewrite. You know what? I'm just going to write it as x to the 5th right now, for now. One step at a time. Okay. Minus the natural log of x minus the natural log of x plus 4. And you just have to be careful because you're subtracting this entire expression. So it's just order of operations, and when you're doing multiplication, it's really addition, but then there's a subtraction sign that was in the front, right? So that's why it's subtraction there. All right, where I'm at. Okay, now let's see if I can't. We could leave it as natural log 9, but 9 is really 3 squared. So I can take that 2 and move it in front. So 2 natural log of 3 is the most reduced form. Let me write that over here. Natural log of 9 is the natural, that's a natural log. Natural log of 3 squared, which is 2 ln 3. Okay, so let's just write it like that because that's definitely the most simplified way to write that. 5 natural log of x, moving the 5 in front, minus the natural log of x minus the natural log of x plus 4. Now we've got each logarithm with only one input. We are good to go. That is completely expanded. Everyone can do this. It's kind of fun, right? You guys are like, yeah, fun. That's exactly what I was thinking, Miss Helbing. Okay, moving on. Okay, so that was expanding, where we took an expression and we expanded it. Okay, we stretched it out. Well, now we're going to condense an expression. Now we're basically working backwards. We're being given something that's been stretched out, and we're condensing it to make it into one single expression. Okay, so, all right. So we're just working backwards. So let's see if we can't take this 2/3 that's in front of this natural log and write that as an exponent. Let's start with that. So I'm going to rewrite this as the natural log of 8 to the 2/3 as my exponent, minus the natural log of 3 to the 4th. Isn't that 81? So that's just going to be minus natural log of, that's just 81 minus 8. Well, now 8 to the 2/3 means 8 squared cube root. The cube root of 8 squared. 8 squared is 64. So I'm going to erase all this, but just to show you. What is the cube root of 64? Well, that's just 4 cubed. So the cube root of 4 cubed is just 4. So 8 to the 2/3 is just 4. So I'm going to rewrite this 8 to the 2/3 as a 4. Minus 81 minus 8 is a 73. Natural log of 73. Well, now we are subtracting two logarithms with the same base. So using our formulas, we can divide them. I'm going to rewrite that. You know what? I'm running out of room. So I'm going to put my arrow, maybe just put a little divisive line here so I know where I'm going here. And I'm going to rewrite this as one expression, because right now we have two terms, right? We just need kind of one. So the natural log of 4 over 73. And I mean, you can simplify that. You can, that's as simplified as it's going to get. I think that's good enough. Let's move on. All right, let's take a look at B. So the first thing I notice is we've all got a base of A. That makes me happy. Okay, so we're going to end up with log base A of and then one term. So let's see if we can't fool around with this and see what we can get. I guess the first thing I'm going to do is move this 4. Nothing I can really do with the first term here. So let me write that as log base A of 18. Okay, minus log base A of 3 to the 4th. I'll write that first. And you could write that as 81 if you want. Let's do that. Let's do that. There we go. 81. Minus log base A of, I'm just going to write this as same as it was. A squared plus 1. And same with this one. Log base A of 5. Well, geez, we only changed really one of them. However, now we've got, notice we're subtracting, and we're adding. So what's going to happen is we're going to do log base A and then anything we're adding, those terms are going to go in the numerator, and anything we're dividing are going to go in the denominator. Because if you look back, I mean, I'm kind of just doing this all in one step, but you'll see addition is multiplication and division is subtraction. So if I kind of do this all in one step, I'm going to get, ooh, where am I going here? This first term is addition, and this last term is addition. So if I mean, I can rewrite those and put those in order, but you'll see that those are going to both be added. So that's going to be the log base A of 18 times 5, which is 90. So that's just 90 over, and then everything we're subtracting is log base A of, is that just an 81? And then A squared plus 1. That's it. Done. That is condensed as much as possible. And the last thing we really need to do is, and we don't really need this as much anymore because we can just use the change of base. Let me show you how to do both ways. Hold on. All right, so the calculator can actually do this for you, and I want to show you how to do that first, and then I'm going to show you how to do it by hand, how we used to do this prior to the calculators being able to do this. So if you just click log, the calculator assumes that it's a base